All right, let's finish up here, and we're going to use the binomial theorem, which I restated here. The only part I didn't put in is that when you're taking a binomial and raising it to an n, it will be the summation, and r goes from 0 to n, that's our counter, n over r, which is equal to something else, which we'll learn a lot more about later. It's the combination, it's a number, and it's the combination of n things taking r at a time, and a to the n minus r and b to the r. And we learned a second ago that this is n factorial r factorial over n minus r factorial. So that's how you calculate this value. And we'll learn much more about what this means and how to use it in other circumstances another day. But for now, just replace this with n factorial, r factorial, n minus r factorial. It'll get you where you want to go. So keeping that mostly in view, I want to find the fourth term. And the expression I'm going to find the fourth term is, I want to use the binomial theorem. So I want to recognize I'm raising this to the seventh. So our a is the 3x, the b is 2y, and this 7 is our n. The only other thing we need to identify is r, and you would think it would be 4 because we're in the fourth term, but it is not. R is always one less than the number of terms. R is one less than the term number. So we were in the fourth term, so r in this case, can you see that? Let me move it. R equals 3. So that's probably the most common place to make a mistake, is not knowing or remembering what R stands for. So, all right, so it's in the fourth term, R will be 3. You could probably think why that might be, because we're starting our calendar at 0. So you can ponder on that. So finding the fourth term, I'm going to feed this information into the binomial theorem. So I'm going to get, right here, since I want the fourth term, I don't have to add the terms up. This is the summation of all the terms. So I can let go of this and just find the fourth term. And it's going to be, the fourth term is going to, the n is still 7, and the r is now I've identified as 3. Our a is 3x raised to the n minus r. N is 7, r is 3, so we're raising 3x to the 4. And then I'm getting 2y, and that's going to be raised to the r, which we've just noted as 3. The 7 over 3 is 7 factorial over 3 factorial times 7 minus 3 factorial. So here we have that expression. Let's see what it is, and we'll simplify the whole thing on the next step. All right. So to simplify, that's why we worked with factorials. Let's go 7 times 6 times 5 times 4 factorial. I'll stop there, keeping my eye on the prize, being 4 factorial. 3 factorial is 3 times 2 times 1, which is the same as 6. So all of that simplified, but down to 7 times 5, or 35. Up here, I'll move it down to here, we have a 3 raised to the 4 and an x raised to the 4. 3 times 3 is 9, times 3 is 27, times 3 is 81, x to the 4th. And now over here, 2 to the 3rd is 8, and y to the 3rd. So with a calculator, I found out that 35 times 81 times 8, I think this is right, is 22,680. And that leaves x to the 4th, y to the 3rd. So this is a fairly quick way to find the fourth term in an expansion, a binomial expansion. And we use the binomial theorem to get there. We could have also used Pascal's triangle and wrote out the expression using that. We would have to go down to the 8th row on Pascal's triangle to get this number. So that's a little bit painful. I'd say these two ways equate. On your assignment tomorrow, you're going to be using binomial theorem for some problems and Pascal's triangle for others. So I think you have been set up then to be successful tomorrow. So get this into your comp book under the title Binomial Theorem, and we will gather tomorrow to work on it. See you then. Good night.